Hey everybody, this is Larry, this is me going Q3 of the bi-weekly contest 135 minimum array changes to make differences equal. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This one, the input is a little bit awkward, but you can change this into two arrays or pairs of numbers where this matches, and you're trying to match it so that the delta, the difference between the two numbers is some number x. So of course that, but the key tricky part about this one is that there is this k constraint. So first of all, let's think about this problem without the k constraint. What would that look like? Well, then what would that look like? I think it's a much easier problem, which is that you just, let's say you have pairs of numbers. Okay, so let's say we have this one, but we reformat this so that it just kind of matches up a little bit better, right? So now you have these numbers. So then now the difference is going to be 4, 4, 4, and 0, right? So what does this mean? That means that if we change it to, and again, let's ignore k for now, right? Just kind of dot process. And because if we try to set x as described in the problem to 4, then we only have to change one number. And you always, if k is unconstrained, then you'll always have to, you could only change one number, because this can be just like whatever, right? Like this could be, whatever the number is, one of the number plus whatever the number, the x is, right? So, you can definitely change that, and that would be, pretty standard, pretty okay. And you just count, and in a greedy way, you just count the max value of here, right? Yeah. This is the max value of all the deltas, right? For example, in this case, 4 is the most frequent value, so we want to change it to 4, obviously, because this only costs 1. However, this problem's a little bit different in that there is a k constraint. So I actually got this part pretty quickly before the k constraints part, because I just misread it, to be honest. And during the contest, a little bit of a retro is that I was just very sloppy. This isn't off by 1, which I'll talk about later. But it also took 20 minutes because I was trying to, this was a hard enough problem that I skipped ahead to Q4. I typed the first part, and then and you can watch this live later. I skipped to Q4, and I thought I could solve Q4, which is why I kind of wasted a lot of time for this problem. So I think this is a hard problem, or like a difficult problem, but not that difficult. It is imaginable. So okay, so then now what can you do, right? Because now we're constrained by this k thing. For example, this k is 6. Well, so the idea that I did is that what is the biggest x that I can change with one thing, right? With one operation, because basically with 2 operations you can always solve this case, right? For example, you just go to no matter what the number is, you could with 2 operations you could change 1 to 0, 1 to x, and there you go. That would be good enough, right? But we have to try to figure out how to differentiate between the 1 operations, and in this case the 2 operations. I'm just going to add an extra 1, which is 5, extra pair of numbers. Here you can see that to get to, this is 2, to get to 4 you change this to 1. So but here, as in example, you have to figure out how to get to 4, but you cannot go 7 and you cannot go -1. So then how do you do it? How do you differentiate this? So the way that I did it is that for each one, for each pair of numbers, I just count what is the maximum x that it can support with 1 operation, right? So here, for example, k is equal to, what is this k? 6, right? So you have 3 and you have 3. That means that for here, if I go to 0, then this is x is equal to 3, right? This is kind of a bad example, but if 3 goes to 6, then x is also equal to 3. So that means that the maximum x that this number can support is 3, and this is another 3, so this is, also the case. But let's use another example of, let's just do, this is a kind of a weird example, but let's say we have 2 numbers 5 and 5, right? So then now here, we know that to get to 0, x can, that's a 0. X could be 5, right? So up to 5, this 5 can go to 0, and that means that we are able to get I think I said this a little bit awkward, but actually, yeah. So no. Let me re-explain this. That means that if 5 goes to 0, then you have 0, 5. So then that means that it could support up to x is equal to 5. Let's say the other direction, 5 goes to 6, then you have 6 and a 5, so this goes to 1. So I think I made a mistake in explaining this a little bit, because this is just a little bit confusing, because they're both 3s, is why it's confusing. But yeah, let's say now you have 5 and a 4, then what happens? Well, there are only 4 operations that you can take, as I said, right? You can go 5 is equal to 6. That means that x is equal to 2, because you have 6 and a 4, right? And then now, let's say 5 is equal to 0. Then you have 4 and a 0, so x can go up to 4, right? And then another way, 4 you can go to 6. So then you have 6 and 5, so x is equal to 1, right? And then this is 0, then now x is going to be 5, right? So that's basically the idea, is that there are only 4 cases of this, and if you change this, then it supports up to 2. And keeping in mind that why we're going to the upper bound and the lower bound from 0 and then the k is because everything in between is going to be between these, right? So that means that here the number 2 means that it can go from 0, 1, 2, right? And you could kind of, imagine that with the other number being 4, it just goes to 4, 5, 6, right? And here we have 0, 1, 2, 2, 3, right? If I could type it right. So you have x is equal to 4, 3, 2, 1, 0, right? Oh, I guess I don't have the 0, 1 here. I mean, either way, right? Yeah. And that means that these are the range of numbers that you could have. And basically you do it for all of these, and you'll notice that because these are all just going, this is 2. These are just from 0 to 2, 0 to 4, 0 to 1, 0 to 5. And so we take the max of these, which is going to be 5. That means that for this pair, x can be equal to 5. Okay, so then what do we do with that information? So then now, the key thing is noting that k is less than n, so we can just brute force all the k's, right? Oh, sorry, not the case. I said that wrong. Sorry. Let me retract a little bit. X can go from 0 to the biggest number, which is 10 to the 5th, because that's just the biggest delta. So that means that x can go from 0 to k, and therefore, and that's not relating to n actually. It just so happens that they're the same, so I misspoke. So yeah, so then now x can be any number from 0 to k, inclusive, which is where I got the wrong answer, by the way. I just kind of was lazy on the typing. And yeah, and that's pretty much the idea, is that, okay, we try, what happens, so we try basically everything, right? So x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, right? Well, in this case, we know that if we have a 5 and a 4, I just have that in here for now. We have a 5 and a 4. This gives us the support. At 5, we need to do 2, right? So that's basically the idea, is that summing all of these up is that, okay, how do we do x is equal to 0? Well, x is equal to 0, we just look at how many counts of zeros do we have, right? So this is just going to be, so we have one delta that is 0. So that means that it's going to be n minus that to get the number of things. And then now we count the number of things where we need an extra number, right? For example, in this case, we have max x column, say, is equal to so the max x column for k is equal to 6. This is going to be 6, right? This is going to be 5. This is going to be 4, I think. This is 3, and this is 5. Yeah. Oh, this is 6 actually. I lied, because I guess this could be 0, and that's, yeah, okay, right. And that means that that means that when we go to 6, or I mean, in this case, it doesn't happen. But if we want to go over 6, that we need an extra number. In this case, we know that if we want an x that's greater than 3, we need an extra number. So that's basically the idea of how to interpret this. And then now here, when x is equal to 0, well, we have 1 0 in 5 pairs. So that means that we can do it in 4 times, or 4 operations. With 1, we have 1 1, so we also need 4 operations, right? 2, well, we have no 2, so we need 5 operations. 3, we also need 5 operations for the same reason. 4, we have 3 4s, right? So we need, technically we need 2 operations at least, but because this max x is 3, we need an extra one. So that's why there's 4 operations, because you cannot get a 4 from these 3, right? And here, 5 is the same thing. We have 5, but one of these is smaller, so this actually takes 5 operations. And 6, same idea. We have 5, but we have 3 operations, so this is going to be 8 operations, right? Just because we have 3 things that require the max x. That's basically the idea, and the whole thing is just about keeping track of all of these in implementation, and that's basically it. Here, let's go over the code real quick. I have n is equal to length, h is just the half of the thing, so it's the number of pairs. Yeah, I don't even think I actually technically need this. I just kind of messed up, to be honest. So here for each pair, this is the frequency of the delta, right? So this is count of the deltas, or the differences, absolute differences, put it that way. And then here, this is just the way to calculate, yeah, and I guess it actually doesn't, I don't need 2 maxes, but before I messed up initially. But yeah, but this is the idea, right? Is that, okay, well, if one of if the other number goes to 0, then this is going to be the max x. If the other number goes to k, this is the max x, and so forth. So we do this for all 4 cases, which is what we talked about, and then we increment, right? And the way that we do this increment is just by a sort of a prefix sum. This is why I have this thing here. So here we brute force x is equal to I, right? Up to k, and yeah, we just kind of keep track of the extra operations that we have to do in a prefix sum kind of way, and it increments every time, or it's not an increment, but every time that x hits that critical spot. I guess you could have actually, this if statement's a little bit awkward. I need to change how, like, you could just do it afterwards, I suppose. I mean, but either way, it's the same code, same idea. Yeah. This is basically, you know, all the numbers that are not already there. This is the number of moves, and this is the number of extra operations. We add the extra operations afterwards, because then now future operations of at least I is equal to x, or x is equal to I will increase, right? That's basically it. What's the complexity here? This is going to be linear time, linear space. You know, this is, well, you can't beat linear time just because you have to look at every element once. And I guess technically this is super linear because you have a k that is not bounded by n. So maybe I lied here. This is going to be O of n plus k. Remember that it's not linear, it's super linear for k, because k is just an integer. But yeah, this is going to be O of n plus k regardless of time. And for space, this is just O of, I guess technically O of k for space, because these lookup tables can only be of size k both here and here. Nothing about n in these cases. Yeah, this is about the value, right? And this is obviously O of k or and O of 1. So yeah, that's all I have for this one. Let me know what you think. Let me know if this is you know, this kind of kicks you off. So like I said, I spent a lot of I thought this was okay, but I spent a lot of time going back and forth between Q3 and Q4, because I thought maybe I had a better shot at Q4, and then come back later because I was stuck behind just this part, the extra thing part. But yeah, did get it actually after realizing that because I was thinking about the cases where we need two, but what flipped the switch to me for me was thinking about the cases where one is good enough. So it was like an inverse thing. So that allowed me to kind of come up with this idea and implemented it. So I did get a wrong answer because I don't know, silly mistake. Still waking up. I had just had this, and I was wrong because it doesn't handle the k is or I is equal to k case. So yeah, I'm just gonna be wrong, right? That's pretty much all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve it live during the contest next. It's a little bit awkward. I could have done the math, but I can't think about it. My brain is not on yet. And it's even and an integer k. One change. And it's big, okay, fine. This integer x. Oh wait. There exists an x such that the difference is the top. Oh, this is 2, okay, fine. Like a weird palindrome kind of thing. This is 4. So this will get doubled up by accident, so it should be even, so that's fine. And then oh no, x is the no, it's the number of changes. So this is the max number. Okay, yeah. Just want it 2, 2. Why do I have 1? Three, 1. What am I doing wrong, Abby? This is 0, okay. Oh, wait. Oh, this has to be less than n. Huh. I mean, at least it's good that they give us this situation. No, that doesn't make sense. You could change it to any number. Oh, no, to k. That's where the k comes from. Okay. At least they're very kind to give us the thing. Huh. Okay. Well, that's a little bit wonky. People probably didn't read it correctly. I didn't read it correctly, to be honest. So, but How do I do it? No, the key matters. No, this is... That is an awkward answer. Okay. I mean, nice of them to give it to us though, because I was confused with this. Because I thought you can only change one of them 6. So if the answer is 6, we want to change it to 4. People didn't get this one yet either, so I guess I can still think about this one. I don't know though. This may be a harder one than I expect. Huh. What is 3? Do they already? No, this is 4. Can I do some operation? K divided by K is 6. So that's why you can't do this to, well, -1 or whatever. Huh. This is a harder one than I thought, but the changes too. What's this? This is 2 and 4. That's the answer. The answer changes, right? So then now, what do we want? We want the min number, maybe? Is that good enough? I don't even know. Three people's gotten is a little bit slow. Huh. No, we have to. How do I do a contribution? Okay, so this one is 0. Prefix sum. Yeah, maybe some prefix something. Okay, so 4 and 0. We've 4, 3, 3. Huh, I don't know how to quite do it. Prefix sum makes sense, but how? So basically, we want to see how. Did anyone get? No, no one got that one either. So we should focus on this then, maybe. Okay. Hmm. These are all 4. Hmm. Can I add or subtract anything? This is 0 together there. I was just rolling along, but all right. Let's take a look at least at this problem. What are we asking here? Grid is the sum of a grid I sub j, such that I sub j is right and horizontal adjacent x score. So okay, so for this one it looks like this, and then still no one's gotten in yet though, so maybe I should not spend time here. But someone told me this one. I don't remember. Or like someone asked me this, I think, or maybe I've seen it somewhere. What is the idea? What's the idea? Hundred. Let's think of this one first. What is the idea that I'm missing? You sum it, you subtract it is fine. So let's say x is due to a sweep line. I don't even know the idea yet. Hmm. So if it's okay, let's say we want to replace by 4. We know that these are 3s. What does that mean? That means that, right, let's say we want x is equal to 1. That's fine. Okay, so 3 means that it max change is going to be 3 on these two. That means that okay, what is the max change here? That means that this is 6, this is 2, now this is 4, right? So that means that you can change up to 4. Okay, so then that means that is f of min I and minus, or k minus nims of I, right? And then the change, so okay, no, this is F2, whatever, too lazy. And then we can do something like okay. And now we can do something like for key in F keys. Okay, now we do FK of keys. Maybe just f of I in range of k. So this is the max number. So okay, so extra is equal to 0. Extra we added by f2 of extra. No, because this is max, so it's going to be I minus 1 maybe, because that's the max. Okay. This is awkward. That's fine. And then best is equal to min best extra plus f of k, or h minus f of k. For how, why? Okay. So 0 extra. Oh, not f of k, f of I. Okay. 3 is still very wrong though. So change to 0 is 3. That's not right. Right. Oh, because 3 is the max number of things. Is h not right? Why is what is h? How do you even have h is 4 because we have 8. Okay, that's fine. So for 0 we have to change 3 things. Okay, that's right. Okay, so this is 1, but extra is 4. Why? Okay, so max is 1. No. 5 means that max is not 1. It is, so the range is going to be the max. So that means that in here it gives not 1 or 5. So we want max of this. Okay, that makes more sense, I guess. Okay. Is this right? I don't know. That's YOLO. Oh no. That is a stupid mistake. Is that right? Why do I have a... Why did I give 9? I think the right ends... Oh, K is 0. But the answer should be 0. That's why, really. Yeah. Because I suck. I'm careless again. Careless again, Larry. Careless! Okay, but we got it. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to good mental health. I will see y'all later and take care. Bye-bye.